Hello, doctor. My name is Surendra Anlaki Balakrishnan. My metric number is CE210102. So today I'm going to present about assignment 2, and I'm from group 5. So these are my group members, Ahmad Izzat and Dayan Anlaki Pratnasamy. So first we go to the introduction. This introduction highlight an advanced water temperature control system designed for industrial environments and emphasizing the use of Kale Vision software and the LPC1768 microcontroller. The system ensures precise temperature control within a specific range 55 degree to 70 degrees Celsius and incorporates features such as PWM control, additional sensor, data logging, and remote monitoring capability. The LPC1768 microcontroller manages communication, data gathering, and temperature regulation utilizing an accurate LM35 analog temperature sensor and effective ADC setup. Real-time monitoring is facilitated through asynchronous serial communication, enabling operators to access temperature data on a computer. The system aims to enhance process efficiency, product quality, and safety in manufacturing facilities by providing comprehensive control and data analysis. Thank you.
Hello Doctor, I Dialen and now I present for our coding for project, and this C code appears to be programmed for microcontroller, especially for the LPC17 access series, right in C. Initialization function ADC init configures the analog to digital converter ADC. PWM init set up pulse width modulation PWM for adjusting LED brightness, and then GPIO initialize general purpose input output GPIO pins, and then the INT init configures interrupts, and then the UART2 initialize UART communication. The timer init initialize a timer, and then the interrupt handles an interrupt triggered by a falling edge on pin P0.15, clears interrupt, turns off the cooler and heater, sets PWM duty cycle to 0. And then the timing function waiters provides a delay in microseconds using timer 3. Peripheral configuration, its various registered to LPC17XX microcontroller are configured for ADC, PWM, GPIO, UART, and then timer. The start button logic, the program waits for a start button press P1.30 before entering the main loop. Temperature based control controls the heater and cooler based on the temperature measured by the ADC. And then the LED brightness control adjusts the brightness of an LED using PWM based on the temperature range. And then the UART communication sends data to the PC via UART. And then the interrupt handling handles interrupt in3 triggered by a falling edge on pin 0.15. And then now I'm going to elaborate for our output that we are get from our coding. Based on the coding, we need to adjust the range for the cooler and the heater, the minimum range and the maximum range, to the pin 0 and then pin 1. If the temperature in lower than 55, it's normal, and then no, the cooler and heater are off. When the temperature in 55 to 90 means the heater is in on, and then it's reached to the 90 temperature, the cooler is on and the heater is off. If there anything happens, the interrupted it will on, and then all the system are with corrected back. Thank you, ma'am.
Assalamualaikum and good morning. My name is Awais Afiq bin Ahmed Sanusi. My matrix number CE200118. So today I will present about the methodology, problem solution, and flowchart. So first of all is the methodology. So for the methodology, We using the temperature control system we built for this project to utilize the microcontroller bearing the plate number LPC1768. And then we doing the thermometer LM35 that provide the temperature as and voltage. Analog voltage to a microcontroller will be the source for the input. The process will verify the cooler and heater and respond the temperature reading in order to maintain the constant temperature and product facility. And then after the project was complete, by using the software which is Scale Vision 5, which integrate development, this period design the develop a programming embedded system is a popular choice for RM-based microcontroller. So it will be including the one used in the temperature control system project. Next was problem solution. So by using the heater and the cooler on this problem solution, we also have the test from the software. This is the result, which is um, when the cooler was off and heater was off, the temperature is between the 55 Celsius until the 80 Celsius, and then the two of both the cooler and heater was off. And then next step, which is when the cooler was off and the heater was on, the input was 01, which is the temperature is below 55 Celsius. And then next, which is when the cooler was on and heater was off, the input was 0. What the input is was 1 and 0. And then temperature is above 80. And lastly, which is the when the cooler and the heater was error, the input was 1 and 1, and the temperature was no condition. Next was flowchart. This is the flowchart from our group, which is first of all we developed the LPC1768 and LM35 sensor by using the software, and then next we do the water temperature is within the range from 55 until the 80. And then next step was when the temperature was 55 below, the system was going to turn on when the heater, and then if the system was no, and it will be off, which is the value is above 55, it will be heater off. Okay, next step is when the system turn heater on, it will be the below 80, which is it will be the cooler was on, and if the above 80, the system was turned off in the cooler. And then next step, when the cooler was on, it will be the keep the temperature in the range in 55 until 80 temperature, and then that's all. So that's all for the flowchart and range between the software between heater and cooler. So that's all from me. Thank you.